Hello everyone and hearty welcome to Math Simplified by HM. Today we are proving a unique Pythagoras rider involving a 3 to 1 base ratio. It's brilliant look at how geometry and algebra intersect. Please take a moment to like, share and subscribe to the channel so you never miss a lesson. Have a great start everyone. Grab a notebook, use the pause button as we go, and let us get started into the proof. Application of Pythagoras theorem. Given and to prove. Given in triangle ABC, seg AD is perpendicular to seg BC and DB is equal to 3 times CD. To prove that 2AB square is equal to 2AC square plus BC square. Now step 1 for this proof, because segment AD is perpendicular to segment BC, we have two right angled triangles, triangle ADB and triangle ADC. In right angle triangle ADB, by Pythagoras theorem, we have AB square is equal to AD square plus BD square. Isolating AD square, we get AD square is equal to AB square minus BD square. Name this as equation 1. Similarly, in right angled triangle ADC, by Pythagoras theorem, we get AC square is equal to AD square plus CD square. Isolating for AD square, we get AD square is equal to AC square minus CD square. Name this as equation 2. From equation 1 and from equation 2, we equate the expressions for AD square. AB square minus BD square is equal to AD square and AC square minus CD square is equal to AD square. So this gives us AB square minus BD square is equal to AC square minus CD square. By shifting minus BD square to the right side, we get AB square is equal to AC square plus BD square minus CD square. Name this as equation 3. From the figure, total base BC is equal to BD plus DC, and given that BD is equal to 3CD, substituting this into our base equation gives BC is equal to 3CD plus CD. This gives us BC is equal to 4CD. Deduce the values of CD and BD in terms of BC. CD is equal to BC upon 4 and BD is equal to 3 into CD. That means BD is equal to 3 into BC upon 4. This gives 3BC upon 4. Substituting our new values into equation, we get AB square is equal to AC square plus in bracket 3BC upon 4 bracket square minus BC upon 4 bracket square. Squaring the fractional terms, we get AB square is equal to AC square plus 9BC square upon 16 minus BC square upon 16. Denominators are equal, so numerators can be added easily. Combining fractions with the common denominator, we get AB square is equal to AC square plus 8BC square upon 16. Simplifying the fraction, AB square is equal to AC square plus 1 upon 2 BC square. We have simplified our equation to AB square is equal to AC square plus 1 half BC square. To clear the denominator, multiply the entire equation by 2. This gives us 2 into bracket AB square is equal to 2 into bracket AC square plus 1 by 2 BC square bracket complete. Simplifying, we get 2AB square is equal to 2AC square plus BC square. That conclude our proof for today. We have demonstrated how a simple 3 to 1 ratio can reveal a complex relationship between the sides of a triangle. Remember, mastering the Pythagoras rider is all about consistent practice and logical steps. A huge thank you to everyone for joining us at Math Simplified by HM. Please take a moment to like, share and subscribe, and make sure to hit that bell icon for future tutorials. Enjoy the great time ahead and keep learning